Hello again, I'm back. We're working with the law of sines on this particular lesson. And basically the law of sines is the sine of A over A equals sine of B over B equals the sine of C over C. And sometimes you'll find books that are actually written as the reciprocal. It's just C over sine. That doesn't matter. I like writing it like this. Anyways, the big letters, A, B, and C, the capital letters, stand for angles. So it's the sine of an angle over, and then this is a side. So lowercase stands for sides, uppercase stands for angles. So why do we do this? Well, what we've been working with is we've been working with 90-degree triangles, right triangles, triangles with 90 degrees in them. Unfortunately, every triangle isn't created equal, and you're going to get triangles that don't have 90-degree measures in it. That is, that one of the angles isn't 90 degrees. Well, how do you solve that? Well, there's a couple of different laws. There's a law of sines and a law of cosines, and we're going to explore the law of sines first. There's two particular cases. With the law of sines, you can be given two angles and then just a side, which is really easy and very convenient to solve. Or you can be given two sides and an angle opposite one of those sides, which we'll get to later. And that one has stipulations behind it. But this one's actually very student-friendly, and students really like it in the end. All they do is just use it in the calculator. And I even plug it into the calculator too, because I can't figure out most of this stuff, you know, as accurately as I'd like to. I can figure it out to an extent, but not perfect. Anyways. So I got this triangle here, I got this example, and it says solve for triangle ABC. And basically what that means is I got to figure out all my angles. I got to figure out angle A, I know it, angle B, I don't know it, angle C, I know it. And I got to figure out all the sides. I got to figure out side A, which I don't know yet, side B, which I don't know yet, and side C, which is 12. Well, that's what we're going to do. We're going to figure out everything. And we're not going to use the law of sines just yet. What we're going to do is we're going to say, okay, well, a triangle has a 180-degree measure in it. All angles add up to 180 degrees. And I know two of the angles, 45 and 55, which add up to be 100. So if these two add up to be 100, and all three of them have to be 180 total, what's B? And B is 80 degrees, because 80 degrees plus 55 plus 45 will equal 180. And if you don't believe me, go ahead and try it for yourself. It'll work. Okay, moving along. Now I can start using the law of sines to figure out what I want to do. I can use two of the three ratios. I don't use all three of them at the same time. You can use this one and this one, the first and the third, or the second and the third. Basically what I do is I set up two ratios equal to proportion, cross multiply, and figure out what I need to figure out. It's really quite beautiful. So here's what I do know. I know that I have the angle and the side for C. I don't have the angle and the side for A. I just have the angle, and I only have the angle for B. So what I'm going to do for sure is I'm going to use this one, because I know both of them. So sine of 55 degrees over its side is 12 equals, and then I ask my students, which one do you want to solve first? Do you want to solve A first, or do you want to solve B first? And most of the time students are going to say A, because A comes before B. So I'm like, okay, so put in what you know. They say, well, okay, I'm going to use this one and this one. Sine of A is sine of 45 degrees over A, which I don't know. So when I do that, all I really got to do is cross multiply and get A by itself. I'm just trying to figure out this one. So that's really all I have to do. So when I cross multiply, that's how I do that. And I can cross multiply because there's an equal between two ratios, and that's how you do it. So I got A sine of 55 degrees, or A times the sine of 55 degrees, equals 12 times the sine of 45. Now students ask the question, you know, does it matter if I put sine of 45 before times 12? No, it doesn't. Just make sure you do it completely right. So I use my calculator right here to try to figure out what I have to do. And I know the sine of 45 actually. It's root 2 over 2 times 12, which is root 2 over 6. I don't know what root 2 divided by 6 is off the top of my head. So when I do that, I'm going to go ahead and plug in the sine of 45 degrees. And you should do that in your calculator too, unless you can happen to figure that out, which is 0.707 or root 2, times 12, 8.48. And what I tell my students is, you know, round to the nearest tenth when you're talking about sides. Even on this step, yeah, sure. Will it affect the answer? Of course it will. The more you round, the more it will affect it, the less precise an answer will be. But if you're just trying to get an answer that's relatively close, then it's not so bad at all. Okay, A times the sine of 55 degrees. Now what I have to do is I have to get A by itself. So I divide by the sine of 55 degrees on both sides. Now what I recommend to my students is, okay, what you do is you take 8.5 and you divide by, and then in your calculator, put in parentheses sine of 55 degrees. So make sure that your calculator reads it correctly. Or you could just, do that save option that students do. So I do 8.5, and I divide it by, this is so emasculating using a calculator as I'm usually used to not using one, but what are you going to do? 55 degrees. And I go ahead and I do that and I get about 10.4. That's my answer. So A is about 10.4. Is it as precise as I want it to be? No, but that's all right. I mean, it doesn't have to be absolutely precise unless your teacher tells you that it has to be rounded afterwards and all that good stuff. I'm just trying to show you in terms of work of what you would do. So A equals 10.4. So that's not necessarily bad. And there's a correlation here, which I'll get to in just a second. Maybe some of you already noticed it between the sides, but if you didn't, that's fine. I will tell you there is one thing I do know for a fact. I know that B is going to be more than 12. I do know that. I'll go ahead and explain that in just a second. But here's what I would do. I would say, okay, I want to figure out B, because I've already figured out A, I already knew C, I figured out angle B, although it didn't really take much effort, figured out angle A, and angle A and C were given. So now I want to figure out B. I say stay consistent. If you use sine of C over C, use it again. It's as simple as that. Don't change it up. If it worked before, don't change it up. So sine of C over C equals sine of B over B is what I would do. So I do that. And then I go ahead and I plug in my numbers, or I substitute in my values appropriately. So I have the sine of 55 over 12. That's degrees, that is not just 55. Pardon me, over 12. Equals the sine of B, which is the sine of 80 degrees, over B, which I don't know. I go ahead and I cross multiply. I don't know what the sine of 80 degrees is off the top of my head, for shame. I know that it's relatively close to 1, and that it's more than 0.866, but other than that I don't really know. Over this. So when I cross multiply, and I'm going to go ahead and I'm going to skip a step here, because I already did it on the previous problem, and I'm running out of room, so I kind of have to assume this. What I'm going to do is I'm going to cross multiply, and then I'm going to cross multiply this, but I want to get B by itself. So what happens is when I cross multiply this, it's sine of 80 degrees times 12 equals B times sine of 55 degrees. Okay? But what I'm going to do is I'm going to, see the sine of 55 degrees is right here, but I'm going to divide sine of 55 degrees on both sides to get B by itself. Hopefully that was pretty self-explanatory. If it wasn't, go ahead and rewind that again and go ahead and check it. So sine of 55 degrees. And again, I'm going to round a little bit. Are my answers going to be as precise as I necessarily want them to be because I round? No. And that's something that you have to take into account. If you round beforehand, then your answer is going to be less precise. If you want the most precise answer, don't round it at all until you get to the end. And that's dependent on teacher preference too. My usual preference is just make sure that students can do the work and get a relatively close answer. And that's what students ask. If I'm off by 0.2, are you going to mark it wrong? And I say no. Because if you were off by 0.2, then you probably turn this 8.48 into an 8.5, and then you did that, and that's fine. But if you're off by 2, if you got like 11.3 instead of 10.5, of course I'm going to mark it wrong because there was something wrong that you did there. But if not, then it's fine. So I do the sine of 80 degrees, which I said I don't know off the top of my head, but whatever. It's 0.984. I knew it was pretty close to 1 times 12. And I'm going to divide it by, and I didn't round anything here, so I'm actually going to just do everything as precisely as possible, at least for this one. Divide by the sine of 55, which equals 14.42. I say just 14.4. I round sides to the nearest tenth when all's said and done. When all is said and done, I round the sides to the nearest tenth and I round angles to the nearest degree. I just find that it makes it easier for students and it's easier to teach it that way too. B is 14.2, approximately. These are approximations, they're not exact. This is obviously exact because it equals 180 degrees for all three of them. Interesting note, just want to point this out really quickly, the smallest angle will give you the smallest side, biggest angle will give you the biggest side, corresponding side. Something to take into account. So if I got a 8 and this was a 12, 55 degrees creates a 12, and 80 degrees better creates something that's bigger than a 12. Something for you to keep in mind. So if you got 8 as an answer as opposed to 14.2, you knew that something was wrong there. So it's something that you have to correct. So that's my first basic introduction to the law of sines. Hopefully that was helpful. We're going to do some more complex cases and we'll see how it goes. But for right now, have a good day. Good luck.